Hi, so today we're going to look at how to calculate gravitational potential energy, which is to do with how high something is above ground and therefore how much energy it has, kind of how much energy it would have as it fell, what's pulling it down, or what indeed is keeping it up. Let me just turn the camera around. So like we did with kinetic energy, the first thing we're going to do is translate this into a triangle so that we can work out what we're doing with it. So gravitational potential energy is EP measured in joules, and that equals mass multiplied by the gravitational field, which on Earth is 9.8 newtons per kilogram. Sometimes you're given 10, multiplied by height. How high is it above the ground? So we're going to put energy at the top of the triangle. And then down here, we're going to put our mass, our gravity, and height. And remembering that this means divide and that these lines would mean multiply. So the first thing we're going to work out is how much energy something has by determining how much of it there is, multiplied by the gravitational strength, which is what's going to give our mass weight, and how high it is above the ground. So knowing that we've got our formula triangle, let's look at that worked example. So Mrs. Harrison is going to go bungee jumping. She has a mass of 80 kilograms, and for the purposes of this, gravity is measured at 10 newtons per kilogram, and the bridge that Mrs. Harrison is going to jump off is 150 meters high. So looking at our formula, we're going to be working out this. So we need to multiply mass by gravity by height. So we've been told that Mrs. Harrison weighs 80 kilograms. So 80 multiplied by gravitational field, which is 10, multiplied by height, which is 150. So I'm going to get my calculator and I'm going to put in 80 multiplied by 10 multiplied by 150 equals, and there we go, 120,000 joules of energy. 120,000 joules of gravitational potential energy at the point where Mrs. Harrison jumps.